The morning of March 6, 1944, arrived cold and crisp over England. At 8th Air Force Headquarters, the mission briefing room hummed with quiet intensity. Chalk dust hung in the air as weather officers worked across blackboards, sketching wind patterns and cloud formations that blanketed Berlin. The target was marked clearly: Reich Air Ministry. The opposition, they warned, would be severe. Colonel Hubert Zemke stood before the tactical map, studying the thin lines that represented one of the war's most dangerous routes. He reached for the secure telephone. 48 Republic P-47 Thunderbolts would fly as escort. The 56th Fighter Group was ready. The 61st Squadron stood prepared. The 62nd Squadron waited on the tarmac. None of them could have known that this particular mission would reveal something aviation history had never seen before. A perfect marriage of durability and devastating firepower that seemed to defy the laws of aerial combat. The European Air War had taught American commanders a hard lesson. Fighters weren't just attack weapons anymore. They were shields. Destroy those shields and bomber formations died by the hundreds. The Luftwaffe understood this. Their Jagdgeschwader 2 and Jagdgeschwader 26 had carved out defensive zones stretching from the English Channel all the way to Berlin. Elite squadrons of experienced pilots waited in those sectors, ready to pounce on any American formation that dared penetrate German airspace. The Germans flew Messerschmitt Bf-109s and Focke-Wulf FW-190s, machines piloted by men who had logged thousands of hours in combat. The American P-47 Thunderbolt thundered through the English sky at 350 miles per hour, a massive frame that displaced more air than any single-engine fighter ever built. 8 tons of metal, armor, ammunition, and engineering precision. Lieutenant Robert Johnson stood on the wing of his P-47, inspecting the battle damage from yesterday's mission. His fighter bristled with protection, armor plating behind the pilot's seat, self-sealing fuel tanks, weapons systems designed specifically to destroy anything that flew in front of it. 8 Browning M250 caliber machine guns, each capable of unleashing 800 rounds per minute. 5-inch high-velocity rockets hung beneath the reinforced wings. But the real secret sat right in the nose of the aircraft, a Pratt & Whitney R2800 double wasp radial engine producing 2,000 horsepower. The R2800 represented American engineering at its finest. Unlike the delicate liquid-cooled engines the Germans favored, machines that failed the moment a coolant line ruptured, this radial engine could lose entire cylinders and keep running. 18 cylinders, each displacing 155.7 cubic inches. The mathematics were brutally simple. German 20mm cannon shells that would destroy a Messerschmitt's cooling system merely damaged individual cylinders on the Thunderbolt. The P-47 achieved survival rates that seemed impossible to German pilots. Traditional fighters died in combat at rates exceeding 10% per mission. The Thunderbolt lost 0.7%. Executive Officer Gerald Johnson had burned those statistics into his memory through weeks of study. West Point education had shaped Johnson into a pilot who understood more than just flying. His mind worked in the language of tactical geometry and mechanical systems. Aerial combat ultimately came down to energy management. Altitude converted to speed at 32 feet per second squared. Track a target, calculate deflection. The difference between a hit and a miss often hinged on whether a pilot truly understood physics and knew how to exploit mechanical advantage. On a German airfield further east, Oberleutnant Egon Meyer sat in the cockpit of his Focke-Wulf FW-190, the designation Black 3 painted on its side. He reviewed his ammunition carefully. 2 MG-151 20mm cannons, each loaded with 250 rounds. 2 MG-17 machine guns carrying 1,000 rounds each. Armor-piercing and high-explosive shells mixed in precise ratios according to hard experience. 102 previous victories had taught him that American bombers required specific attack angles and careful ammunition management. But these new escort fighters posed different problems. Intelligence reports described the P-47 as heavily armored and absurdly difficult to destroy. The reports insisted on concentrated fire directed at critical components. Meyer had perfected the head-on attack against B-17 formations, 4 to 5 20mm hits from the front would bring a bomber down. 20 hits required from other angles. But the P-47s seemed to absorb damage that made mockery of those calculations. Pilots returned with aircraft carrying over 200 bullet holes, engines missing entire cylinders, control surfaces shredded, wings punctured by cannon shells. The American formations assembled over East Anglia as the morning broke. 3 squadrons weaving in search patterns as they climbed toward escort altitude. 1 squadron positioned to port, 1 to starboard. The 56th Fighter Group holding the center. Each Thunderbolt swept the sky with Mark IV gun sights and carefully calibrated weapon systems. The pilots maintained their 4-ship flights, formations refined through months of combat. Every few degrees they turned. They checked their blind spots constantly. They scanned the sky for contrails. The weather cooperated perfectly, clear skies ideal for seeing enemy aircraft at extreme range. But the cold was brutal. -40 degrees Fahrenheit at altitude. Contrails became inevitable above 25,000 feet. White plumes that advertised their position to every German pilot within 100 miles. At 9:15 on the morning of March 6th, Johnson's flight spotted the enemy formation, 16 Fokker-Wulf 190s climbing from the east, bearing 090 degrees relative. Johnson pressed the radio transmit button and adjusted his gun switches. "Bandits, 3 o'clock high, 16 plus, closing fast," he reported. In Meyer's cockpit, the fighter controller's voice cut through the radio static. Enemy fighters approaching from the west. American escort accompanying the bomber stream. Meyer ordered an immediate combat climb, full throttle, emergency boost engaged. The BMW 801 radial engine screamed as methanol water injection kicked in, boosting power to 2,100 horsepower. The climb rate jumped to 3,300 feet per minute, 4.5 minutes to combat altitude. Executive Officer Johnson plotted intercept geometry on his knee pad. Enemy speed approximately 350 miles per hour. Closure rate roughly 600 miles per hour. The Germans held an altitude advantage of 2,000 feet. The Thunderbolt's critical altitude was 30,000 feet, where the turbo supercharger performed best, but this engagement would occur at 27,000 feet, territory where both aircraft types fought effectively. The first engagement erupted at 9:23. 8 P-47s dove from 29,000 feet in a carefully calculated bounce designed to convert altitude into speed and surprise. The Thunderbolts accelerated past 450 miles per hour in their descent. Armor-piercing incendiary tracers streaked through the morning air. No hits, a clean miss. The Germans had broken formation at precisely the right moment, their superior roll rate allowing them to evade. Johnson recalculated. The enemy reaction time was faster than he'd expected, probably 2 seconds from visual acquisition to evasive action. He ordered a different approach angle and prepared for a second attack. At 9:31, the second bounce scored multiple hits. Concentrated fire from 4 Thunderbolts hammered a Fokker-Wulf's engine. Black smoke streamed from the damaged fighter, but the pilot maintained control. Johnson could see the German fighter's propeller still turning. The aircraft remained maneuverable despite obvious damage. The BMW 801 radial engine proved nearly as tough as the American R-2800. The third attack came at 9:35. Johnson had calculated the deflection angle at 30 degrees, but wind drift affected bullet trajectories. The streaming fire passed behind the target. Meyer's wingman executed a defensive barrel roll at the precise moment, exploiting the Fokker-Wulf's superior roll rate of 160 degrees per second. Standard evasion tactics that had kept Luftwaffe pilots alive throughout the defensive campaign. The fourth attack succeeded when Lieutenant Walter Beckham caught a Fokker-Wulf in a climbing turn. 8 machine guns concentrated their fire for a 3-second burst. 400 rounds of .50 caliber ammunition hammered the German aircraft. The Fokker-Wulf's wing route failed. The aircraft tumbled into an unrecoverable spin. No parachute appeared. At 9:42, Meyer led his formation in a head-on attack against Johnson's flight. Closing speed exceeded 600 miles per hour. Time in effective gun range measured less than 2 seconds. Both formations opened fire at 800 yards. Tracers crisscrossed through the morning sky like a deadly weaving pattern. Johnson's P-47 shuddered as 20mm cannon shells found their mark. 3 hits in the engine cowling, 2 hits in the right wing, 1 hit in the tail section. Oil pressure began dropping, cylinder head temperature climbed upward, but the engine continued running. The massive R-2800 double Wasp had absorbed damage that would have destroyed any other fighter. 2 cylinders were compromised, compression lost, but 16 cylinders continued firing. Oil leaked from punctured lines, but redundant systems maintained pressure. The turbocharger, protected by armor plating and mounted in the rear fuselage, remained untouched. Johnson reduced power to 75% and turned toward home. 20 minutes later, Johnson touched down at Halesworth. Ground crews counted 43 bullet holes and 5 cannon strikes. The aircraft would fly again after 2 days of repairs. The pilot walked away uninjured. The mission had demonstrated the fundamental truth underlying the P-47's design philosophy: survivability through redundancy, power through excess capacity, victory through mechanical superiority. But the broader tactical implications were only beginning to emerge. The real test of the P-47's extraordinary resilience had actually occurred months earlier. On June 26, 1943, the 56th Fighter Group had encountered Jagdgeschwader 26 over France. 48 Thunderbolts against 16 Fokker Wolves. The mathematics seemed to favor the Americans, but experience and favorable position gave the Germans significant advantages. What followed would become the most famous demonstration of the P-47's survivability in aviation history. Lieutenant Robert Johnson flew as Tail End Charlie in the 61st Squadron formation, the most vulnerable position traditionally assigned to newer pilots as part of their combat education. His P-47C-2RE, serial number 41NA6235, carried the name Half Pint painted on its cowling. Standard armament of 8 0.50 caliber machine guns, each carrying 350 rounds. The formation cruised at 26,000 feet, approaching Abbeville when German fighters struck from above and behind. The first indication of attack came from exploding ammunition. 21 20mm cannon shells ripped through Johnson's fuselage in the opening 2 seconds. The instrument panel erupted, the canopy shattered. Hydraulic fluid sprayed into the cockpit. A cannon fragment sliced across Johnson's nose. Machine gun bullets punched through the oxygen system. Fire erupted behind the engine cowling as fuel lines ruptured. Johnson's P-47 rolled inverted and entered a spin. Centrifugal force pressed him hard against the canopy. The altimeter unwound through 20,000 feet, then 15,000, then 10,000. Standard recovery procedure: opposite rudder, forward stick, neutral ailerons. No response. The fire spread along the fuselage. Ammunition began cooking off in the wing magazines. At 4,000 feet, the fire suddenly died. Fuel starvation or oxygen depletion at lower altitude had snuffed the flames. The spin stopped. Johnson regained marginal control. The canopy release mechanism had been destroyed by cannon fire. The plexiglass was partially melted, trapping him inside. Manual escape was impossible. The engine ran rough, missing on multiple cylinders, but maintained power. Oil covered the forward windscreen. Forward visibility was 0. Peripheral vision limited to gaps in the shattered side panels. Navigation by compass was impossible. The instrument lay destroyed. Johnson turned west toward the channel by instinct and sun position. Altitude 1,000 feet. Airspeed unknown, the indicator destroyed. Engine temperature unknown, gauges shattered. Fuel quantity unknown, though fuel leaked steadily from multiple punctures. The English Channel lay 50 miles distant. German territory stretched beneath him. Anti-aircraft positions dotted the coast. Fighter bases at Abbeville and Poix waited to pounce. The probability of reaching England seemed minimal. Then Johnson spotted the worst possible sight. A Fokker Wolf FW-190 approached from behind, its blue and yellow nose marking visible even through the oily haze. An expert pilot, Johnson was defenseless. His gun sight was destroyed. Hydraulic pressure read 0, meaning no gun charging capability, even if the weapons somehow functioned. Speed approximately 200 miles per hour, barely above stalling. The German fighter positioned for the killing shot. The FW-190 opened fire at 300 yards. Machine gun bullets hammered Johnson's P-47. The sound was overwhelming. Metal shrieked as rounds punched through aluminum. The armor plate behind Johnson's seat rang like a bell as round after round struck it repeatedly. Fabric shredded, control cables frayed. The instrument panel, already destroyed, disintegrated further. Johnson hunched forward, making himself as small as possible behind the armor plate. The German pilot, later identified in some accounts as Egon Meyer, though this remains disputed, fired with professional precision. Methodical bursts, calculated shooting. The FW-190's ammunition loadout included 1,000 rounds of 7.92mm for the machine guns alone. He was using them. The 20mm cannons had already been depleted during earlier fighting. For the next 3 minutes, the German pilot unleashed round after round into the wounded American fighter with methodical precision. Careful bursts preserved what ammunition remained, each shot deliberately targeting vital systems. The engine nacelles, the wing structures, the control surfaces, the fuel tanks themselves. Johnson's Thunderbolt endured the relentless assault and stayed airborne. The massive R2800 engine, now operating on just 14 cylinders instead of 18, somehow maintained sufficient power to keep the wounded bird flying. The control surfaces, though torn and battered by repeated strikes, still answered to the stick in Johnson's hands. Those self-sealing fuel tanks, punctured again and again, refused to surrender catastrophically. The rubber linings did their job, preventing the explosive loss of fuel that should have sent the P-47 tumbling from the sky. The German pilot pulled alongside to get a better look at his prey. Through the spider-webbed wreckage of his canopy, Johnson found himself staring directly at his attacker. The German's head moved slowly from side to side, a gesture of pure disbelief. No machine should possibly continue flying after absorbing such devastating punishment. Yet here it was, still flying, still dangerous. The Fokker-Wulf dropped back to prepare for yet another assault. Machine gun fire ripped across the wings, tore through the fuselage, and hammered the tail section. Bullets stitched their deadly pattern across every surface. The elevator trim tabs disintegrated under the onslaught. The rudder absorbed repeated impacts. The aileron surfaces were shredded by bullet strikes. Impossibly, the Thunderbolt kept flying. The German pilot pulled alongside once more. His ammunition was running low, or perhaps something deeper. A kind of respect, maybe even resignation, had taken hold. He glanced directly at Johnson, rocked his wings in what might have been a warrior's acknowledgement, then banked away toward France. Johnson descended toward the English Channel at 500 feet, the engine running rough now, power draining away, oil pressure dropping toward zero. The English coastline eventually materialized through the oil-smeared windscreen. RAF Manston was roughly 10 miles inland. With no functioning radio, with all his instruments dark and useless, Johnson had no way to communicate his critical condition. He approached the aerodrome at the lowest possible altitude, trusting someone on the ground would recognize the desperate plight of a crippled fighter. What followed was less an orthodox landing than a controlled catastrophe. No flaps, hydraulics were destroyed. No brakes, destroyed for the same reason. The main landing gear, locked down through emergency procedures, held firm. The Thunderbolt roared down the entire runway length before grinding to a halt in a cloud of dust and smoke. Fire crews and ambulance teams rushed toward the aircraft. They encountered an immediate problem. The canopy refused to budge. Cannon damage had warped the mechanism beyond function. Firemen swung axes into the plexiglass, chopping it away in large chunks. Johnson hauled himself out, drenched in hydraulic fluid, streaked with blood from superficial wounds, coated in engine oil. He walked the perimeter of his battered machine and began attempting to tally the damage. He abandoned the count at 200 holes visible on just the right side of the fuselage. Subsequent careful examination revealed at least 21 impacts from 20mm cannon shells and more than 200 punctures from machine gun rounds. One cannon shell had pierced the armor plate mounted directly behind Johnson's seat without detonating. A perfect 20mm hole that, had it struck half an inch in either direction, would have ended his life permanently. The damaged machine was declared beyond salvage, written off as destroyed and irreparable. Yet Johnson climbed into a fresh P-47, just 4 days later. He would eventually accumulate 27 confirmed aerial victories, claiming his place among America's elite aces in the European theater. His survival on June 26, 1943, transformed into legend among Thunderbolt pilots. It became proof that their aircraft could absorb punishment that defied logical comprehension and still deliver their pilots to safety. For the Luftwaffe, the psychological impact was profound and troubling. Intercepted German radio communications and captured pilot reports revealed mounting anxiety among German aviators regarding American fighters that seemed impossible to destroy. The phrase Eisenflugzeug, iron aircraft, began appearing in German pilot combat reports. Luftwaffe training documents were hastily revised to stress that P-47s required concentrated attacks using 20mm cannon fire aimed at identified weak points. The turbo supercharger intake, the oil cooler, the cockpit. Yet even these refined tactics produced only marginal success. Captain Fred Christensen of the 62nd Squadron managed to nurse his damaged Thunderbolt home after absorbing 47 machine gun strikes and 6 20mm cannon impacts on July 29, 1943. Lieutenant Ralph Johnson flew his crippled machine back to base with an entire cylinder shot away from his engine on August 17. Captain Walker Mahurin brought his P-47 down, looking like Swiss cheese after action on October 4. The airframe so severely damaged, it required 6 weeks of intensive repairs before returning to the fight. The 56th Fighter Group's chief engineer, Captain Barney Wazowicz, meticulously analyzed and catalogued the damage patterns. Most impacts concentrated on the engine area and cockpit region, precisely where German pilots anticipated maximum destructive effect. The R2800 engine proved remarkably resilient, continuing to produce power even with 3 complete cylinders torn away or inoperable. Oil loss could be managed by reducing power output and increasing cooling circulation. The turbo supercharger, positioned in the rear fuselage, benefited from protection provided by the pilot's armor plate and fuel tank placement. Only direct hits from the heavier 30mm cannon shells consistently destroyed P-47s, and few German fighters carried such heavy weaponry. The mathematics of survival painted a compelling picture. By December 1943, the 56th Fighter Group had accumulated 5,847 combat sorties. Enemy action destroyed 56 aircraft. Enemy action killed 34 pilots. The loss rate calculated to approximately 0.96% per sortie. The Luftwaffe fighter units engaging American bomber formations suffered losses exceeding 15% per mission. The attrition rate was fundamentally unsustainable for German forces. Technical investigation revealed why the P-47 survived so effectively. The R2800 engine architecture incorporated inherent redundancy. 18 cylinders arranged in 2 rows of 9 each. Twin magnetos provided independent ignition systems. Dual oil circulation systems meant that even catastrophic damage still allowed partial power. The sheer frontal area, though it created aerodynamic drag, simultaneously offered protection to the pilot seated behind it. Incoming fire had to penetrate 6 feet of engine block before threatening the cockpit. The airframe structure exceeded the construction standards of its era. Wing spars withstood loads reaching 12 G-forces. Control cables ran in duplicate, with independent emergency backup systems. Fuel tanks received armor plating plus self-sealing rubber liners. Ammunition magazines were positioned to prevent chain reaction explosions. Every component received design consideration for combat damage scenarios. Republic Aviation's Farmingdale production facility on Long Island manufactured P-47s at unprecedented scale. Daily production peaked at 16 complete aircraft. Total production eventually surpassed 15,683 machines, more than any other American fighter aircraft. American industrial output, combined with aircraft survivability, created a strategic advantage German forces simply could not overcome. For each P-47 destroyed in combat, 10 more entered the fight. Pilot training expanded to produce qualified aviators faster than combat losses could eliminate them. By spring 1944, P-47 fighter groups had decisively achieved aerial dominance over Western Europe. The victory ratio reached 4.6 American kills for every aircraft lost, yet the genuine measure of success lay in bomber protection. Before long-range fighter escorts existed, bomber crews suffered losses exceeding 10% on each mission. With P-47 protection, losses fell below 2%. That mathematical difference translated into thousands of air crews who lived who would otherwise have perished. Major General William Kepner, commanding the 8th Fighter Command, fully recognized the Thunderbolts' singular importance. The aircraft proved that survivability ranked as critically as raw performance. A pilot who trusts his machine completely to absorb severe damage fights with boldness and aggression born from genuine confidence. The psychological advantage proved incalculable. German military analysis reached identical conclusions. Luftwaffe General Adolf Galland reflected in his post-war writings that the P-47 was essentially a flying tank. Our pilots learned they must avoid prolonged engagements with Thunderbolts unless they possessed overwhelming numerical superiority. These American machines seemed to transcend the physical laws that governed our aircraft. Tactical evolution reflected these mechanical realities. Colonel Hubert Zemke pioneered the Zemke fan formation, leveraging the P-47's exceptional durability to design flexible protective patterns. Rather than rigidly maintaining close formation directly above bombers, P-47s ranged widely ahead and along the flanks, intercepting German fighters before they could assault the bomber stream. This tactic demanded aircraft capable of surviving damage while operating independently. Only the Thunderbolt possessed adequate structural strength. The Zemke fan's power became evident on February 11, 1944. The 56th Fighter Group, ranging ahead independently of the bomber formation, discovered 60 German fighters assembling for coordinated attack. During the subsequent engagement, P-47s destroyed 17 enemy aircraft while losing just 2 of their own. Multiple damaged Thunderbolts returned home bearing battle damage that would have guaranteed the loss of conventional fighters. Lieutenant Roach's machine returned with the entire left elevator control surface shot away. Captain Francis Gabreski brought his aircraft down running on 12 cylinders with his engine cowling perforated by cannon strikes. Gabreski would eventually become the highest-scoring American ace in Europe, achieving 28 confirmed victories, every single one scored in a Thunderbolt. His particular aircraft endured multiple instances of catastrophic battle damage. On November 26, 1943, a 20mm cannon shell detonated within his turbo supercharger at 30,000 feet. Boost pressure vanished instantly. Gabreski managed to glide 80 miles toward friendly territory, the R-2800 engine somehow furnishing just barely enough power to prevent a forced landing deep in enemy territory. Ground attack missions revealed yet another dimension of Thunderbolt survivability. Operating at minimal altitude against heavily fortified targets, the P-47s faced concentrated anti-aircraft fire of multiple calibers. Light flak, 20mm and 37mm, poured upward at rates exceeding 120 rounds per minute. Heavy flak, 88mm, created lethal explosions at predetermined altitude layers. The mathematics of survival seemed to defy possibility, yet P-47s regularly returned from ground attack missions that would have been suicidal for other aircraft types. On December 23, 1944, during the Battle of the Bulge, the 56th Fighter Group flew close support missions in conditions that grounded most aircraft. Visibility reduced to barely 1 mile, clouds hanging at 400 feet. Thunderbolts attacked German armored columns at absolute minimum altitude. Captain Robert Brooking's P-47 sustained 87 hits from small arms and automatic weapons. He flew back to base missing cylinders, oil streaming from the engine cowling, controls barely responding to input. The damage was repaired and the aircraft flew again 72 hours later. The 9th Air Force, focused entirely on tactical ground support, maintained extensive documentation of P-47 damage statistics. Between June 6, 1944 and May 8, 1945, Thunderbolts completed 135,000 ground attack sorties. Enemy fire damaged 4,293 aircraft. Enemy fire destroyed 824 aircraft. The survival rate among aircraft that sustained battle damage reached 80.8%. No other aircraft type achieved comparable survivability in the ground attack role. Lieutenant Colonel Kinnard's experience on January 1, 1945, exemplified this Thunderbolt resilience. Attacking a German train, his machine struck high-tension electrical wires. The propeller blades twisted and bent. The engine cowling crumpled inward. The oil cooler system was destroyed. Kinnard managed to fly 40 miles back to base with the engine temperature climbing toward critical limits, touching down just as the engine finally seized completely. Within a week, the aircraft had received an engine replacement and returned to combat. The cumulative impact on German forces proved devastating. Thunderbolts destroyed 86,000 railway cars. They destroyed 9,000 locomotives, 6,000 armored vehicles, 68,000 trucks. German transportation infrastructure supporting military operations collapsed. Not through precision bombing from high altitude, but from P-47s that absorbed ground fire, which would have destroyed conventional attack aircraft and pressed home their attacks with unrelenting determination. The Pacific Theater presented different obstacles, but yielded comparable results. Thunderbolts operating from Philippine bases faced Japanese anti-aircraft fire and fighter opposition. The vast oceanic distances meant that a single engine failure translated directly to ditching in waters filled with sharks. Yet P-47s posted the lowest loss rate among all fighter types deployed in the Pacific. The R-2800 engine's fundamental reliability, even when wounded, saved countless pilots from water landings in hostile seas. Colonel Neil Kirby, commanding the 348th Fighter Group, demonstrated Thunderbolt combat effectiveness throughout the Pacific campaign. On October 11, 1943, leading just 4 P-47s, he encountered 36 Japanese aircraft. The resulting battle saw Kirby personally destroying 6 enemy machines. His own Thunderbolt took multiple impacts from Japanese 7.7mm and 12.7mm machine guns, yet continued operating effectively. Kirby accumulated 22 victories before overwhelming Japanese numbers finally achieved, on March 5, 1944, what individual aerial combat could not accomplish. The Japanese military designated the P-47 as monster for its massive size and apparent indestructibility. Japanese pilot training materials emphasized avoiding engagement with P-47s unless possessing clear numerical advantage. The traditional Japanese tactic of brief firing passes and rapid disengagement proved ineffectual. Short-burst attacks failed to inflict sufficient damage. Prolonged fighting exposed Japanese fighters to the Thunderbolt's devastating firepower. Manufacturing statistics demonstrated industrial dominance. Republic Aviation's Farmingdale facility sprawled across 2.5 million square feet. At peak employment, 24,000 workers labored in production. The Evansville, Indiana facility provided supplementary capacity. Combined production exceeded Germany's total fighter aircraft output by enormous margins. The industrial reality was absolutely clear. American manufacturing capability, joined with superior aircraft survivability, created an insurmountable strategic advantage. Cost analysis proved equally illuminating. A single P-47D cost roughly $85,000 in 1944 currency. Training a combat-ready pilot represented a $75,000 investment. Together, the total reached $160,000. If a Thunderbolt's superior survivability preserved even one pilot from death or capture, the investment paid for itself. Throughout the conflict, P-47 durability saved hundreds of pilots who would certainly have perished in less rugged aircraft. The 56th Fighter Group concluded the war as the top-scoring American fighter group in Europe, with 677.5 confirmed aerial victories. All victories achieved exclusively in P-47s, despite considerable pressure to transition to P-51 Mustangs. The group's commander, Colonel David Schilling, explained the decision simply. We continued flying the Thunderbolt because our pilots had absolute faith in the machine. They understood that however severely damaged, the P-47 would probably deliver them safely home. Individual survival episodes accumulated across the months into powerful legend. Lieutenant Quince Brown's Thunderbolt collided with a Focke-Wulf 190 on February 8, 1944. 3 feet of his right wing simply tore away from the airframe. The engine cowling was crushed inward. The propeller blades bent badly. Brown flew 200 miles back to base and landed successfully. The aircraft underwent repair and returned to service. The German pilot did not survive the collision. Captain Johnson McGinn endured a direct hit from an 88mm anti-aircraft shell on March 24, 1945. The projectile punched through his right wing without detonating, creating a hole large enough for a man to pass through. McGinn nursed the machine home, with the wing flexing visibly with each control input. When Republic's engineers examined the wreckage and damage, they stood amazed at what they discovered. The wing structure had somehow held together in ways that seemed impossible. Their calculations showed that virtually any other fighter of the era would have simply fallen apart under the same punishment. What they learned from this durability would reshape how aircraft were designed after the war ended. Years later, when the A-10 Thunderbolt II took to the skies in the 1970s, its designers looked directly back to the P-47 for inspiration. They studied how the original Thunderbolt had survived, noting the redundant hydraulic systems that kept working even when damaged, the armor that protected what mattered most, and the way engines were positioned high to stay clear of ground fire. Every decision traced back to hard lessons learned in combat decades earlier. The philosophy wasn't just about looking backward. It was about understanding something fundamental that pilots and crews had discovered. Veterans spoke with consistent amazement about their trust in these machines. Lieutenant Colonel Robert Baszler, who flew the P-47 throughout the war, put it simply, "I never worried about the airplane failing me. Engine problems, battle damage, things breaking that shouldn't still work. The Thunderbolt handled it all. That confidence meant I could focus on fighting instead of worrying whether I'd make it home." German pilots saw things from an entirely different perspective, and their frustration was real. Heinz Baer, a Luftwaffe ace with 220 victories, expressed what many of his comrades felt. "The P-47 was our most frustrating opponent. We would score hits that should destroy any aircraft, watch pieces fly off, see smoke and flames, yet the Thunderbolt would continue flying and often shoot back accurately. It defied our understanding of how combat damage should work." The maintenance crews who kept these aircraft flying had their own stories to tell. Sergeant Anthony Garzino serviced P-47s throughout the European campaign and witnessed things that seemed impossible. "We'd see Thunderbolts return with damage that made no sense," he recalled. "Cylinders shot completely off, oil lines severed, control cables hanging by threads. We'd work through the night and that plane would fly the next day." It was designed not just to be flown, but to be fixed. The numbers supported what everyone was seeing firsthand. When the 56th Fighter Group analyzed their maintenance records, the results were startling. Within 72 hours, 73% of damaged aircraft had been returned to service. Major structural repairs were completed within 2 weeks. Aircraft were only permanently removed from inventory when they were completely destroyed or lost over enemy territory. This repair rate had never been achieved in any previous war. The supply chain supporting P-47 operations represented industrial warfare at its absolute peak. Pratt & Whitney produced 125,000 R-2800 engines during the war, and each one contained 2,800 individual parts that had to be manufactured and assembled with precision. The entire supply system had to work flawlessly to move engines, spare parts, ammunition, and fuel across global distances. A damaged P-47 sitting in England could receive replacement parts manufactured in Connecticut within 10 days. The logistics were staggering. Each Thunderbolt carried 3,400 rounds of 50 caliber ammunition when fully loaded, and the 56th Fighter Group alone expended over 10 million rounds during the war. Every single one of those rounds had to be manufactured, shipped, and loaded onto aircraft. The logistical achievement matched the combat success in scope and complexity. Yet behind all these numbers was something more profound. Behind every survival story stood a pilot who lived because his aircraft had absorbed punishment that would have killed him in any other fighter. When those survival stories were multiplied across thousands of missions, it meant thousands of families who welcomed their fathers, sons, and husbands home after the fighting ended. Lieutenant Colonel Francis Gabreski, the highest-scoring P-47 ace, understood what it all meant. The P-47 gave us confidence to engage superior numbers, attack heavily defended targets, and press our attacks home even when damaged, he explained. We knew the Thunderbolt would take care of us if we took care of it. That mutual trust between man and machine was what won the air war. The final numbers were compelling in their simplicity. From start to finish, 15,683 P-47s were manufactured. Of those, 3,499 were lost to all causes in combat. Pilots flew 746,000 combat sorties. The aerial kill ratio stood at 4.6 to 1. The loss rate per sortie was just 0.7%. Behind these statistics lay a fundamental truth. The P-47 Thunderbolt's unprecedented survivability had changed how aerial warfare worked. By the war's end, German pilots had developed a grudging respect mixed with fear for the P-47. Official Luftwaffe training documents from early 1945 stated clearly, avoid engagement with P-47 formations unless possessing overwhelming numerical superiority and tactical advantage. If engaged, attempt to damage the oil cooling system or turbo supercharger intake. Do not expect single hits to destroy the aircraft. The American Thunderbolt has proven capable of sustaining damage that would destroy any German fighter. The legacy went far beyond combat statistics. The P-47 proved that design philosophy could prioritize survivability without sacrificing combat effectiveness. Other fighters had emphasized performance above all else. The Thunderbolt demonstrated that keeping pilots alive was just as important as shooting down enemies. This philosophy would influence military aviation for the next several decades. When Republic's test pilots and engineers analyzed what made their creation so tough, they found that every component had been overbuilt by the standards of the time. Wing spars were designed to handle 12G loads when 9G was considered adequate. Control cables were doubled in thickness. Fuel lines were routed through protected channels. Engine mounts were reinforced to survive crash landings. The weight penalty was accepted as the price of keeping pilots alive. The Thunderbolt's large size, initially viewed as a disadvantage, turned out to be one of its greatest strengths. The big fuselage provided room for armor protection, redundant systems, and structural reinforcement. The massive R2800 engine itself served as frontal armor. The wide landing gear track enabled safe landings even with damaged tires. Everything that seemed like a weakness contained hidden strengths. Combat tactics evolved to exploit these advantages. Experienced P-47 pilots attacked from altitude, diving at over 500 miles per hour. After their attack, they'd zoom climb, converting speed back into altitude to stay away from danger. They made head-on passes where the engine provided protection. Every tactic required an aircraft capable of absorbing damage while maneuvering aggressively. The industrial story paralleled the combat narrative perfectly. Republic Aviation had started small, producing just 30 aircraft monthly in 1941. By 1944, the company was manufacturing 500 per month. The workforce expanded from 3,000 employees to 24,000. Manufacturing techniques evolved to support mass production while maintaining quality standards that pilots' lives depended upon. Quality control at Republic was legendary throughout the industry. Every engine was test run for 8 hours before installation. Every aircraft was test flown before delivery. Manufacturing defects that might cause combat failures were ruthlessly eliminated. Signs throughout the factory reminded workers, "A pilot's life depends on your work." The employees understood exactly what that meant. The learning curve was steep, but the results were worth it. Early P-47B models suffered from engine problems, radio failures, and canopy malfunctions. Each problem was systematically identified and corrected. By the time the P-47D arrived, reliability had improved dramatically. Later versions like the P-47D-25 incorporated lessons learned from thousands of combat missions. Survival features were continuously refined based on detailed analysis of battle damage. Pilot training evolved to exploit what the P-47 could do. The aircraft's weight and power required different flying techniques than lighter fighters. Energy management became critical, maintaining speed in combat, using vertical maneuvers instead of horizontal turning battles, trusting the aircraft to absorb damage while pressing attacks. Training programs at bases from Bradley Field in Connecticut to Millville in New Jersey produced pilots capable of maximizing every P-47 advantage. The contrast with German aircraft was stark and obvious. The Messerschmitt Bf-109's liquid-cooled engine failed with single hits to the coolant system. The Focke-Wulf F-190's BMW 801 radial engine was more robust but still vulnerable to oil system damage. Neither possessed the armor protection, redundant systems, or structural strength of the P-47. German pilots fought knowing that serious damage typically meant death or capture. Intelligence assessments confirmed what the psychological impact was doing. Intercepted German communications revealed growing reluctance among pilots to engage P-47 formations. The Luftwaffe's morale declined as pilots witnessed seemingly destroyed Thunderbolts continuing to fly while their own aircraft fell to single bursts of .50 caliber fire. Medical reports from the Luftwaffe even documented something new: Thunderbolt fever, an anxiety disorder affecting pilots assigned to intercept P-47s. The Pacific Theater provided different but equally important validation. Operating over vast ocean distances, engine reliability literally meant survival. With the nearest friendly base sometimes 500 miles away, an engine that could keep running despite damage was the difference between life and death. Navy pilots flying Grumman F-6F Hellcats and Vought F-4U Corsairs, also powered by R-2800 engines, reported similar survivability advantages. Maintenance crews in the Pacific developed remarkable expertise born from necessity. They repaired damage that seemed impossible by conventional standards. In forward airfields, they replaced cylinders, reconstructed control surfaces using salvaged materials, and overhauled engines under combat conditions. The P-47's design made field repairs possible that would have required factory facilities for other aircraft. The spare parts system was revolutionary for its time. Republic established part numbering systems that became industry standards. Every component was catalogued, tracked, and distributed based on usage patterns. High-priority items were pre-positioned at forward bases. The result was unprecedented aircraft availability rates exceeding 80%, despite continuous combat operations and battle damage. Combat photography documented what everyone already knew. Gun camera footage showed Thunderbolts absorbing streams of cannon fire while maintaining controlled flight and fighting back. Post-mission photographs revealed aircraft that seemed impossible to fly. Wings had gaping holes, fuselages resembled colanders with damage everywhere, engines had cylinders blown completely away, yet these aircraft had returned to base under their own power, ready to fly again. The cost-benefit analysis was overwhelmingly positive. A P-47 that survived severe damage saved not just the pilot, but the entire investment in training and experience. Veteran pilots were irreplaceable assets. Their survival meant continued combat effectiveness. The Luftwaffe's loss of experienced pilots, by contrast, created a downward spiral where capability kept declining. Weather operations demonstrated yet another survivability advantage. The P-47's robust construction enabled operations in conditions that grounded other aircraft. Ice accumulation that would destroy lighter fighters was manageable. Turbulence that would cause structural failure was absorbed. Rain and mud that made operations impossible for German aircraft were routine for Thunderbolts. Even limited night operations proved feasible. P-47s equipped with exhaust flame dampeners and basic night-flying instruments conducted true missions over German airfields. The aircraft's stability and predictable handling made it suitable for instrument flight. Several pilots survived night combat damage that would have been fatal in aircraft, requiring more precise control. The culmination came during the Rhine crossings in March 1945. P-47s flew continuous ground support missions in the face of desperate German resistance. Concentrated flak batteries filled the sky. Emergency Luftwaffe fighter sorties launched. Man-portable anti-aircraft weapons fired from the ground. The Thunderbolts absorbed unprecedented damage while maintaining operational tempo. Not a single Allied unit reported failure of air support due to P-47 losses. Colonel Hubert Zemke, reflecting on his command of the 56th Fighter Group, stated it clearly. The P-47 changed the fundamental equation of air combat. Previously, the aircraft with superior performance held the advantage. The Thunderbolt proved that survivability could overcome performance disadvantages. Our pilots learned they could accept battle damage that would destroy our enemies and continue fighting. That psychological edge was decisive. By May 8, 1945, P-47s had flown more combat sorties than any other American fighter. They had dropped more bombs, fired more rockets, and destroyed more ground targets. Most importantly, they had brought more pilots home alive, despite sustaining battle damage that defied conventional understanding of aircraft survivability. German ace Adolf Galland offered a final assessment that was telling in its honesty. The P-47 was not the best performing Allied fighter. The Spitfire turned better. The P-51 had longer range. The P-38 had better visibility. But the P-47 was the fighter we feared most because it could not be stopped. Our pilots called it the unbreakable. In the end, that quality proved decisive. The last P-47 combat mission in Europe came on May 7, 1945. Appropriately, the aircraft returned with battle damage, 23 bullet holes from German fire. The pilot was uninjured. The aircraft would have flown again if the war had continued. It was a fitting final demonstration of the quality that had stunned German pilots throughout the conflict. The P-47 Thunderbolt's ability to survive everything. The legacy lived on in pilot memoirs, technical manuals, and design philosophies that shaped aviation for generations. Every modern military aircraft incorporates lessons learned from P-47 combat experience: redundant systems, damage tolerance, armor protection, structural over-design. The principles that saved thousands of Allied pilots continue protecting military aviators today. In the final analysis, the P-47 Thunderbolt represented more than just successful aircraft design. It embodied an American industrial philosophy of overwhelming material superiority, combined with innovative engineering. It proved that technology could provide decisive advantage when properly applied. Most importantly, it demonstrated that prioritizing pilot survival was not just humanitarian, but strategically essential. German pilots who faced P-47s in combat never forgot the experience. In post-war interviews, veteran after veteran described the shock of seeing Thunderbolts absorb damage that would destroy any aircraft in their experience and continue fighting effectively. The psychological impact of facing an apparently indestructible opponent contributed significantly to the Luftwaffe's ultimate defeat. The statistics were staggering, but the human story was more important. Behind every number was a pilot who survived because American engineers had built an aircraft that refused to die. Families reunited, children grew up with fathers, communities welcomed home their heroes. The true victory of the P-47 Thunderbolt was measured not in enemy aircraft destroyed, but in American lives saved. The Thunderbolt had proven that in the brutal mathematics of aerial warfare, survivability could be as decisive as firepower or performance. German pilots had been stunned to discover their opponents flew aircraft that seemed to violate the fundamental laws of aviation physics. The P-47 absorbed punishment that should have been fatal and kept flying, kept fighting, kept bringing its pilots home. That was the legacy of the Republic P-47 Thunderbolt. Not just victory, but survival. Not just air superiority, but the preservation of trained air crews who would continue fighting until the enemy was defeated. In the skies over Europe and the Pacific, the Thunderbolt had written its legend in armor, steel, and American determination. It was quite simply the fighter that survived everything.